Einstein's theory of relativity shattered the classical notion of absolute time, replacing it with the concept that time is relative, dependent on the observer's velocity and gravitational environment. Time dilation, a cornerstone of relativity, manifests in two ways. Special relativity describes how time slows for an object moving close to the speed of light, while general relativity explains how strong gravitational fields also stretch time. This isn't just theory, it's been experimentally confirmed. The Hafeel-Keating experiment, for instance, placed atomic clocks on planes flying around the Earth and found measurable differences in elapsed time compared to clocks on the ground. Similarly, GPS satellites, orbiting Earth and moving at high speeds, experience both forms of time dilation, necessitating adjustments to keep their systems accurate. But how does this relate to human experience? Our conscious perception of time, seemingly linear and unyielding, is inherently subjective. Could this subjectivity mirror the relative nature of time itself, hinting at a profound interplay between consciousness and the space-time fabric? While physical time can be precisely measured, psychological time is elusive and profoundly shaped by human consciousness. Moments of joy, fear, or boredom alter our perception of time. A thrilling experience might feel fleeting, while waiting in discomfort seems interminable. Neuroscience attributes this to our brain's temporal processing, which relies on dopamine levels to regulate the perception of duration. Studies, such as those conducted by the University of Minnesota, have shown that heightened emotions slow our internal clock, causing us to perceive time differently. This psychological time resonates with time dilation. Both demonstrate that time's flow is not fixed but influenced by context. Could this subjective temporal flexibility suggest that consciousness is more than a passive observer of physical time? Perhaps the mind's ability to reshape time perception hints at a deeper connection between the neurological and cosmological dimensions of time. Imagine traveling close to the speed of light, where time for you slows dramatically compared to those at rest. This relativistic phenomenon, famously illustrated in the twin paradox, shows how one twin on a high-speed journey ages slower than their earthbound sibling. While this effect remains theoretical for human travelers, its principles have been tested with subatomic particles. Muons, created in Earth's atmosphere, decay slower when moving at high velocities, corroborating Einstein's predictions. If humans could experience such journeys, how would consciousness adapt to this altered flow of time? Would memory formation, decision-making, or awareness adjust to the relativistic slowdown? Or are these processes hardwired to Earth's time frame? Exploring these questions invites us to consider whether consciousness is tied to the physical processes of the brain, or if it possesses a more universal, time-independent essence that transcends such relativistic constraints. General relativity predicts that time slows in stronger gravitational fields. Near a massive object like a black hole, time dilation becomes extreme, with time effectively freezing at the event horizon relative to distant observers. Observations of the supermassive black hole at the center of our galaxy, Sagittarius A*, have confirmed these effects as seen in the redshift of light escaping the intense gravitational field. But what would happen to consciousness under such conditions? If an astronaut were to hover near a black hole, they might experience seconds while years pass for observers far away. This scenario raises profound questions. Would the mind operate normally within such extreme temporal distortions? Intriguingly, mystical experiences often describe timelessness, a state uncannily similar to what relativistic physics predicts. Could gravitational time dilation provide a physical framework for these altered states of consciousness, offering a bridge between science and spirituality. The flow state, often described as being in the zone, is a mental state of deep focus and heightened performance where time seems to vanish. Athletes, artists, and scientists frequently report this phenomenon, where hours feel like minutes. Neuroscientific research links flow states to changes in the brain's default mode network, a system associated with self-referential thinking and mind-wandering. When the default mode network quiets, our sense of self and time often dissolves. Could this psychological state be a subjective analog to the relativistic stretching of time? If consciousness can temporarily transcend our ordinary perception of time, it might reflect a deeper, universal truth about the malleability of time itself. Relating these timeless experiences to relativity opens a new avenue for understanding how human consciousness might mirror the cosmos. Einstein's theories reshaped our understanding of the universe, challenging the notion of absolute time and space. Yet consciousness, often described as the hard problem of science, remains poorly understood within this framework. Theoretical physicist Carlo Rovelli argues in The Order of Time that time may not be fundamental but emergent, a construct arising from interactions at the quantum level. If this is true, consciousness might also emerge from or interact with this temporal fabric. Furthermore, timeless states described in spiritual traditions, from the Buddhist concept of no time to the eternal present in mystical experiences, align intriguingly with relativistic and quantum ideas. Could consciousness be the bridge between the subjective experience of time and its physical properties? Exploring these intersections deepens our understanding of both the universe and ourselves, revealing a cosmos where time and consciousness are intertwined in ways we are only beginning to grasp.